student, in solid geometry chapter 6 we start exercise 6.5. Question first, find the coordinate of the point where the line x plus 3 by 4 is equal to y plus 4 by 3 is equal to z minus 8 by 5 intersect the sphere x square plus y square plus z square plus 2x minus 10y is equal to 23. The given equation of sphere. Given equation of sphere x square plus y square plus z square plus 2x minus 10y is equal to 23, and equation of line x plus 3 by 4 is equal to y plus 4 by 3 is equal to z minus 8 by 5 and minus. This equation of straight line intersect the sphere. So we find out the point of this straight line. Now the point is, let this straight line is equal to k constant. Then the point of this straight line, first we put x plus 3 by 4 is equal to k. This implies x is equal to 4k minus 3. Y plus 4 by 3. Then y plus 4 by 3 is equal to k. This implies y is equal to 3k minus 4. Now z minus 8 by 5 minus is equal to k. This implies z is equal to 5k minus plus 8, and this minus symbol here. So point P x y z as P point 4k minus 3, 3k minus 4 minus 5k plus 8. This straight line intersect the sphere, so this point lie on this sphere. P point lie on this sphere first. So we put this point in the sphere first. We find out 4k minus 3 square plus 3k minus 4. We put 3k minus 4 in place of y. 3k minus 4 square plus minus 5k plus 8 square 2 into 4k minus, then it becomes k square minus 3r plus 2 is equal to 0. After solving this factor, k square minus 2k minus k plus 2 is equal to 0. Factor of this equation k minus 1, k minus 2 is equal to 0. This implies k is equal to 1 or 2. Putting these two values of k in this point, we find out point P 1 minus 1 3 and 5 2 minus 2. So this straight line intersect the sphere at 2 points P and Q. These 2 points P and Q. Now we solve next question. Show that the line, this is the equation of straight line, touches the sphere. Now equation of sphere, it is given equation of sphere x square plus y square plus z square minus 6x plus 2y minus 4z plus 5 is equal to 0, and equation of straight line x minus 7 by 2 y minus 4 by 7 z minus 13 by 10 is equal to k constant. Now we find out the point of this straight line, P point. Let point P. Then the x minus 7 by 2 is equal to k, y minus 4 by 7 is equal to k, z minus 13 by 10 is equal to k. So we put both the points, we put the equal, then x minus 7 by 2 is equal to k, then the point x is equal to 2k plus 7, y is equal to 7k plus 4, z is equal to 10k plus 13. This is the point which lie on the sphere, sphere first. Then we put x is equal to 2k plus 7, y is equal to 7k plus 4, z is equal to 10k plus 13. This equation of sphere becomes 2k plus 7 square plus 7k plus 4 square plus 10k plus 13 square minus 6 2k plus 7 plus 2 into 7k plus 4 minus 4 into 10k plus 13 plus 5 is equal to 0. After solving this equation for the value of k, we find out the equation 153k square plus 306 k plus 153 is equal to 0. Here we find out the roots of k, values of k. First of all, we divide this equation by 153. Then we find out the equation k square plus 2k plus 1 is equal to 0. This equation became k plus 1 square is equal to 0. This implies k is equal to minus 1 minus 1. Both the values of k are same. Then the straight line cut the sphere at a single point. So that single point touches the sphere. Both values are same. Then this is the sphere. This is the sphere and the straight line at a single point. So this straight line touch the sphere at the point P point. K is equal to minus 1 put in this point. Then the point becomes 9, 11, 23. When we put the value k is equal to minus 1 in this point, then this point P is P 9, 11, 23. This point becomes. So this straight line touches the sphere at a single point. Now next question. Find the locus of the center of sphere of constant radius which passes through a point and touch a given line. Find the locus of the center of sphere. Then we find out the answer in the coordinate of centers of sphere. Which coordinate of centers? We find out locus of center. So u, v, w are the center of the sphere. We find out locus of center, so u, v, w becomes x, y, z. And answer in the center of a sphere. First of all, we take the equation of sphere. Let equation of a sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Here equation of sphere is not given, so we take the general equation of sphere. Center of the sphere, minus u minus v minus w. We find out the answer in u, v, w. Here it is given that equation of sphere of constant radius which passes through a given point. So point is given and touch a given line. This equation of sphere passes through a given point. We We take the point on x-axis, y-axis, z-axis. So we take this given point on a z-axis. Here we take on x-axis is a0, 0. Also we take this point on y-axis 0, b0. We take the given point on a z-axis and a given line. So and given line, we take given line as a x-axis. First point is this sphere passes through a given point 0, 0, C. Second point, this sphere touch a given line as x-axis. So this sphere touch a given line. Second point, sphere first touch a line x-axis. Touch a line x-axis. And also given third point is of constant radius. Then the radius of sphere first. Third point, this sphere first has a constant radius. First of all, when sphere first passes through a given point, sphere first passes through a given point 0, 0, C. Then the equation becomes 0, 0, C, C square, 0, 0, C. Then C square plus 2WC plus D is equal to 0. This equation second. Second point, equation of sphere touches the given line, touches the x-axis. Sphere first touches the x-axis. When this sphere touches the x-axis, sphere first touches the x-axis at that point on x-axis. So where y and z are 0. Sphere touches x-axis at that point. Which point lie on x-axis? So y and z are 0. Y and z 0, then equation of sphere first becomes yz 0 only in x. Then x square plus 2ux plus d is equal to 0. This equation in second degree of x, this gives two values of x. But x-axis will touch sphere first. So touch, then these two values of x given by this equation are same, because this equation touches the sphere. When equation of line touch the sphere, then both values are coincident. Both values are same. So here both values of x will be equal. We find out the value x1, x2 minus b plus minus b square minus 4ac under root by 2a by this method. We find out both values by this method. When both values are same, then this discrement is equal to 0. Discrement b square minus 4ac is equal to 0. Then both values minus b by 2a are equal. B square minus 4ac is equal to 0. Discrement is equal to 0. Here we find out discrement minus b square minus 4ac. This implies 2u square minus 4ac d is equal to 0. 4u square minus 4d is equal to 0. U square is equal to d. We find out the value of d. Now we find out third condition. This sphere has a constant radius. this sphere has constant radius, then we take u square plus v square plus w square minus d is equal to k square. This is the equation 4th. And equation 3rd, and equation 4, u square minus d, u square minus d. Here we find out the value of d is equal to u square. We put this value of d is equal to u square in equation 2nd and in equation 4. Put the value of d in both equation 2nd and equation 4. Then we find out u square plus v square plus w square d minus u square is equal to k square. U square cancel u square to u square, then v square plus w square is equal to k square. And now the value of d we put in this equation, then c square plus 2wc plus u square is equal to 0. Both the equations are in v and w, u, v, w. We find out the locus of the center of sphere. Then the coordinate of center u, v, w. So both these equations represent the locus of the center of sphere. Now we find out locus. Locus, u becomes x, v becomes y, w becomes z. So locus of the center of sphere, v square y square plus w square z square is equal to k square, and c square plus 2wc wz 2zc plus u square x square is equal to 0. Both the equations represent the locus of the center of a sphere. Now next question. Prove that the locus of the center of sphere. Locus of the center of sphere. So we find out the answer of this equation in the coordinate of center of sphere. Then this center becomes locus, which passes through a given point and touch a given plane. Now in this equation here it is given that given plane, we take plane is a conchoid. So locus of the center of sphere, first of all we take the equation of sphere. Let equation of sphere. Equation of sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Center of this sphere. Center of this sphere minus u minus v minus w, and the radius. Radius of this sphere u square plus w square, u square plus v square plus w square minus d under root. Now in this equation it is given that this equation of sphere which passes through a given point and touch a given plane. Here we take a given point and a given plane. So let P point 0, 0, C be the given point. That is equal to 0 plane. So equation of sphere, we take equation of sphere as a first equation. So this first equation passes through 0, 0, C point. So equation of sphere becomes c square plus 2wc plus d is equal to 0. Because in this equation of sphere we put x is equal to 0, y is equal to 0 and z is equal to c. Then the equation of sphere becomes, this is the equation second. Also sphere first. Equation of sphere first, touch the plane. Z is equal to 0. So sphere first touch the plane, z is equal to 0. This is the sphere. Touch the plane this plane is z is equal to 0. Touch at a point. Center of this sphere minus u minus v minus w. It is given. So we find out the condition. The perpendicular distance from the center to the plane. Perpendicular distance from the center to the plane is equal to radius. This is radius, or this is also perpendicular distance. So perpendicular distance is equal to radius. Here we find out perpendicular distance. Find out perpendicular distance from the center to the plane is equal to radius. Both are equal. Radius is given u square plus v square plus w square minus d under root is equal to. Here we find out perpendicular distance. For find out perpendicular distance, we put this point. We find out perpendicular distance from this point. So we put this point in the plane. We put minus u at the point x, minus v on the place y, minus w on the place z. Here in this plane, here only z. So we put minus w. Then perpendicular distance, in the place of z we put minus w. Here x and y are not given, so minus u minus v we can't put. Divide by coordinate of x, y, z. 0 is the coordinate of x, 0 is the coordinate of y, and the coordinate of z is 1 square under root. So perpendicular distance is w. We squaring both sides to remove under root. Then u square plus v square plus w square minus d is equal to w square. So cancel w square to w square, then the equation became u square plus v square minus d is equal to 0. Now to remove d, here we find out the value of d, u square plus v square. This value of d we put in equation second. So this value of d, u square plus v square, we put in this equation. Then the equation second becomes c square plus 2wc plus u square plus v square is equal to 0. This is the equation in the center of sphere. Then we find out the locus of the center of sphere. Then we put in place of u x, in place of v y, and in place of w is z. Then the equation of locus of center of sphere becomes c square plus 2wc plus 2zc plus x square plus y square is equal to 0. This is the locus of the center of a sphere. Center of sphere is minus u, minus v, minus w. Then minus w. W becomes minus z. Then minus z. C square minus 2zc plus x square plus y square. This is the equation of center of sphere. Now next question. Show that the locus of the points from which the tangents to the three spheres are all equal. We find out the tangent of length of tangent of these three spheres. Equation of first sphere x minus 2 square. Equation of first sphere plus y square plus z square minus 1 is equal to 0. S1. Let S1 first sphere. Then after solving this sphere, x square plus y square plus z square. X square plus y square plus z square minus 2 into 2x. So minus 4x. Minus 4 minus 2 square plus 4 minus 1 plus 3 is equal to 0. This is the equation of first sphere. Now the equation of second sphere. Then S2 is equal to x square plus y minus 3 square plus z square minus 6 is equal to 0. After solving this equation, x square plus y square plus z square minus 2 into 3y minus 6y plus 9 minus 6 plus 3 is equal to 0. Equation second. Now the sphere third. X plus 2 square plus y plus 1 square plus z minus 2 square is equal to minus 6 is equal to 0. After solving this equation, we find out x square plus y square plus z square plus 4x plus 2y minus 4z plus 3 is equal to 0. Now we find out the length of tangent for these three spheres from any point. Let point P, x1, y1, z1. This is the point, any point, on the required locus. Then the length of tangent from the point P to the sphere first, second, third. Now we find out the length of tangent from the point P to the sphere first, second, third. Then the length of tangent from the point P to the sphere first. We take this T1. T1 is the first length of tangent from the point P to the sphere first. Then length, we find out length of tangent. We put the point x1, y1, z1 on in the sphere and under root. Length of this is the sphere. This is the point P, x1, y1, z1. This is the length of tangent. For this length of tangent, we find out this is the radius of the sphere. This is the center of the sphere. And this is the PC distance. We find out this distance by distance formula. This point is given, this point is given, this is the radius, this is the perpendicular. We find out the length of tangent. Length of tangent PT square is equal to PC square minus TC square. By this formula we find out that this point x1, y1, z1 simply put in this sphere and we take under root. So the distance T1 is equal to, we put x1, y1, z1 in this sphere first and this under root, x1 square plus y1 square plus z1 square minus 4x1 plus 3 under root. Similarly T2, length of tangent from the point P to the second sphere, x1 square plus y1 square plus z1 square minus 6y1 plus 3. Similarly, length of tangent from the point P to the third sphere, x1 square plus y1 square plus z1 square plus 4x1 plus 2y1 minus 4z1 plus 3. And in the statement it is given that length of tangent to the three spheres are all equal. Then these three distances T1, T2, T3 are all equal. Three distances are equal. So T1 is equal to T2 is equal to T3. So T1 is equal to T2 is equal to T3. Then three distances are equal. Equal distances, we cancel the under root. Now we take first and second part, second and third part. First we take first, second. First is equal to second, second and second is equal to third. From the first two relations, x1 square plus y1 square plus z1 square minus 4x1 plus 3 is equal to x1 square plus y1 square plus z1 square minus 6y1 plus 3. x1 square, y1 square, z1 square cancel out. 3 to 3 cancel out. Only minus 4x1 is equal to minus 6y1. 2x1 is equal to 3y1. We can return this. From this we can return, multiply 3 with y1, we can divide 3 and multiply 2, we can take here 2. This equation can be written this. from first two relation. Now we take second and third relation. X1 square plus y1 square plus z1 square minus 6y1 plus 3 is equal to x1 square plus y1 square plus z1 square plus 4x1 plus 2y1 minus 4z1 plus 3. Now x1 square, y1 square, z1 square. Then this equation minus 6y1 plus 3 is equal to 4x1 plus 2y1 minus 4z1 plus 3. Now in this equation minus 6y1, 2y1. 3 to 3 cancel out. Now 2y1 we can take here. Minus 6y1 minus 2y1 is equal to 4x1 minus 4z1. Here the value of x1, 2x1 is equal to 3y1, 2x1. 2 into 2x1 minus 4z1. Value of 2x1 is equal to 3y1 from first two relation is equal to 2 into 3y1 minus 4z1. Here minus 6y1 minus 8y1. And this is this 6y1 minus 8y1 minus 6y1 is equal to minus 4z1. It becomes minus 14y1 is equal to minus 4z1. Minus 2 minus cancel out, 2 2 cancel out. 7y1 is equal to 2z1. We can then take here y1 by 2 multiply by 7. We can take here 7. And this is from first and second relation. This is second and fourth relation from 4 and 5. 4 and 5. y1 by 2, y1 by 2. We can take x1 by 3, y1 by 2, z1 by 7. This is the exercise 6.5 in the chapter sphere. Thank you.